Good afternoon, students. So today we will be discussing on alkenes. In the last chapter, the last segment was the alkane part, that was called saturated hydrocarbon, and now we are talking about alkene. Now let me discuss with the general molecular formula. What is the general molecular formula of alkene? The general molecular formula of alkene is CnH2n. Okay. In the last segment, we discussed that general formula of alkene was CnH2n plus 2. Now, in case of alkene, it is CnH2n. Now, you can see here that in case of alkene means carbon-carbon double bond must be there, and carbon-carbon hybridization is sp2 hybridization of each carbon which are associated through double bond. Okay. Now, what is the kind of bonding that this compound has, that we will talk about now. That you can see that among two bonds between two carbon atoms, that means I am talking about double bond, one bond is sigma, another bond is pi, right? Now you can see over here that one bond is sigma and another bond is pi, right? Next bonds, all the other carbon hydrogen bonds are sigma bonds, right? Now what are the preparations of these alkenes? So let me discuss all these things. First of all, you can just synthesize this alkene from alkyne compound, that means from triple bonded compound, right? Now you can see over here that this is a triple bonded compound called ethine or acetylene. It is actually reacting with hydrogen in presence of palladium charcoal or palladium carbon. Okay, it actually reducing this ethine or alkyne to reduce it to the ethene, a double bonded compound. Because we know addition of hydrogen is called reduction, na? So hydrogen will be added here, one hydrogen will be added here, so it will be CH2, another hydrogen will be added here, it will be CH2, so CH2 double bond CH2 will be formed, right? Now this is the preparation of alkene or ethene from alkyne. Now you can prepare the alkene from haloalkane, okay, from haloalkane. If you take CH3CH2Br as an example, and if you just react it with alcoholic KOH solution, and if you heat it, then what will happen? The hydrogen will be eliminated from the carbon number 2, and the bromine will be eliminated from the carbon number 1, and the double bond is formed between carbon number 1 and carbon number 2, that you can see over here, right? And what is the mechanism? Alcoholic KOH you are giving as an reagent. Alcoholic KOH means OH minus. This OH minus is actually taking out the proton from here, from this carbon, and it is making the double bond over here, and the Br minus is being eliminated, right? So alkene is being formed, right? So these are the preparations of alkene. So you can prepare alkene from alkyne by reducing it with hydrogen and palladium carbon, or you can synthesize the alkene from alkyl halide, that means CH3CH2Br, okay, alkyl halide, alkyl bromide or alkyl halide, by reacting it with alcoholic KOH solution just by heating it. Okay, so proton will be eliminated from the carbon number 2 and bromine will be eliminated consequently from carbon number 1, and there will be a double bond formed between them, right? Now let's talk about the next synthesis processes of alkenes, right? Now, alkenes can also be prepared from dihalo compound like this. You can see over here that two bromine atoms are attached with two consecutive carbon atoms, and an alkene is forming here. What is the reagent? Zinc in acetic acid. Okay, zinc in acetic acid is actually eliminating these two bromine atoms, and a double bond is formed between these two carbon atoms. Okay, and alkene is formed, right? So zinc acetic acid is an important reagent by means of which you can synthesize the alkene by taking 1,2-dibromo compound. This is one carbon number 1, this is carbon number 2. So 1,2-dibromo, two bromine atoms are there. So 1,2-dibromo compounds are being formed, right? So when 1,2-dibromo compound reacts with zinc in acetic acid medium, zinc actually take out these two bromine atoms in the form of ZnBr2, and this alkene is being formed here, right? So this is the preparation number 3. Now let's talk about the preparation number 4. You can prepare alkene from the simple alcohols. It is a simple alcohol. It is also a simple alcohol. When these type of alcohols react with concentrated H2SO4 at a heating condition, Concentrated H2SO4 has a tendency to absorb water. So where it will get this water molecule? It will get the water molecules from the OH will be going from this carbon atom, and the hydrogen will be going from this carbon atom. So what is the alkene that will be formed? CH3. The hydrogen will be gone, so it will be CH, and a double bond will be formed here because OH minus is eliminating. So CH3 CH double bond CH2. This is your product. Okay. Now let's talk about the addition reaction of alkene. Now let's talk about the reactions of alkene. So when alkene reacts with nickel hydrogen, it is a reducing system. It will convert into an alkane, right? So it will form RCH2 CH3. RCH2 CH3. Alkene on reduction gives alkane. What is the reducing system? Who is actually reducing this compound? Hydrogen in presence of nickel. Now addition of halogen. Halogen could be added in an alkene compound. This is an alkene, and it is being added with bromine molecule. So two bromine atoms will be connected here, and 1,2-dibromo compound is being formed. Right. Now the water molecule in presence of bromine can also react with the alkene part and to form this type of compound. So what we are observing here? We are observing that the two bromine atoms could be attached with the two consecutive carbon atoms to form this compound. What is the reagent? Bromine in CCl4 solvent. Bromine molecule in CCl4 solvent. Okay, and in the next case, you can, if you use the bromine water, then bromine will be added here and OH will be added here. Water contains OH, na? So OH will be added here, bromine will be added here, right? And when you will use the bromine in CCl4 solvent, the two bromine atom will be attached in these two carbon atoms and forming this compound. Okay. Now let's talk about Markovnikov's rule. This is the important rule. You have to be very careful about this rule. So let's talk about Markovnikov's rule. So what is this rule saying? This rule is saying, one second. This rule is saying that whenever you are adding a molecule to alkene compounds, that means double bonded compound, then the negative part of the molecule that you are adding gets attached to that carbon atom, which possesses lesser number of hydrogen atoms. Now you can see over here, it is an alkene compound, and it is first reacting with H plus of HBr, and it is forming the this carbocation, this positive charge, because the bond is opening in this way and catching the hydrogen ion, and the positive charge appears on the head of carbon atom over here, and the next step, the Br minus of HBr is adding here and forming this product. Right. Now another possibility is that hydrogen could be attached in this carbon atom and positive charge comes here. In the first case, carbon is positive, this second carbon is positive, and this hydrogen is attaching here. In the second case, this carbon is getting the positive charge and the hydrogen is attaching here. So you can see this carbon becomes CH, double bond turns into single bond, and this CH2 turns into CH2 plus. Now in the next step, Br minus is adding here, will be added here in this carbon atom and forming this products, right? Now you can see over here that CH3, CH3, CH, CH3, and this CH2 plus will be combined with this Br minus to form CH2Br, right? So what is this rule basically saying? The rule is basically saying the negative part of the molecule gets attached to that carbon atom which possesses lesser number of hydrogen atom, right? Now here you can see that among these two carbon atoms which are connected by double bonds, among these two carbon atoms, since this carbon atom contains less number of hydrogen atom, in fact it doesn't contain any hydrogen atom at all, right? So this carbon contains two hydrogen atom, this carbon contains no hydrogen atom, right? So obviously the negative part of the molecule HBr, that means Br minus, will be added on this carbon atom according to this Markovnikov rule, right? So you can see Br is adding here in this carbon atom and hydrogen is adding here in this carbon atom, in carbon number 1. So this is going to be your main product. Along with it, another alternate product will be formed where the bromine atom will attach to this carbon atom and hydrogen will attach here. So this compound is formed. So question could come in this way, that what is Markovnikov's rule? Explain with example. So you can take any alkene example. I am taking here this example, okay, to explain this phenomenon. Okay, so whenever a molecule is added to an alkene, the negative part of the molecule, here Br minus is the negative part na, of HBr. So the negative part of the molecule will be added to that carbon atom which contains less number of hydrogen atoms. Since this carbon contains less number of hydrogen atoms, so Br minus will be added here, and this is going to be your main product. Main product in the chemistry is called major product, and this product is side product called minor product. Okay, why it is major? According to the Markovnikov's rule, right? Now another rule is very important in the respect of this Markovnikov's rule is anti-Markovnikov rule or anti-Markovnikov addition of HBr with alkene, and it is also called Kerr's effect or peroxide effect. Clear? So what is this rule basically saying? This rule is saying that whenever you are adding a molecule to an alkene compound in presence of any peroxide, peroxide means mainly the compounds which contains oxygen single bond, like hydrogen peroxide H2O2, like benzoyl peroxide. It is the formula of benzoyl peroxide, C6H5 C double bond O bond O bond O CO C6H5. So here you can see oxygen single bond linkage is there. So whenever you will find a compound which contains oxygen single bond, it will be termed as peroxide compound. So this is benzoyl peroxide, it is a peroxide compound. So whenever you will add this HBr molecule or any molecule to an alkene, then the negative part of the molecule will be added to that carbon atom which contains more number of hydrogen atom. Now Br minus is the negative part of this molecule HBr. So Br minus will be added to that carbon atom which contains more number of hydrogen atom. Since this carbon contains 2 hydrogen atoms, so Br minus will be added here. So you can see over here that Br minus is adding here, and the hydrogen part will be added here. So CH is turning into CH2, right? Now the thing is, you can see over here a term that is called unsymmetrical double bond. This type of Markovnikov rule and anti-Markovnikov rule will be applied to those compounds which is actually unsymmetrical. What do you mean by that? The meaning of this term is that this alkene is totally unsymmetrical. Why? Because you can see that these two carbon atoms are joined by double bond, and before this carbon atom, with this carbon atom there is a methyl group attached, but with this carbon atom there is no group attached at all. So obviously it is an unsymmetrical system. Here also you can see the 2 methyl groups are in this carbon atom, but there are no methyl groups in this carbon atom. So obviously it is also an unsymmetrical alkene. So obviously Markovnikov rule and peroxide rule or Kerr's effect or anti-Markovnikov addition will be applied to double bonds which are unsymmetrical, right? So let's talk about the next segments. Now here you can see that the mechanism of unsymmetrical addition of anti-Markovnikov rule or unsymmetrical addition mechanism is not in your syllabus, so I am not getting into it. Okay, now addition of water. Okay, so when this is the fourth reaction that I am talking about. So here you can see that the alkene part is reacting with water in presence of concentrated H2SO4 and to give you the alcohol product. Clear? Now you can see, you can tell me, sir, why H2SO4 is actually acting here as a supporting agent. Concentrated H2SO4 always absorbs water, na? And I am giving water in presence of concentrated H2SO4 or in presence of H2SO4. Here in this reaction, H2SO4 acts as a supporting system, which is actually acts as a catalyst. What is the function of catalyst? Catalyst actually makes the reaction faster, right? So it makes the addition of water to this molecule, that means to this alkene, faster. That means here H2SO4 acts as catalyst. So whenever you will add water in presence of H2SO4 or in presence of simple H+, H2SO4 means H+, na? H2SO4 is an acid, that means H+. So what will happen? The OH part of water will be added, since it is negative part will be added here in this carbon atom, forming this product, and the hydrogen part of water will be attached here, forming CH3. Okay, now you can tell me, so it is actually the Markovnikov's product that is actually formed here, right? Now another system, another product you will find where the OH group will be added here. In the second example you can see that here the OH group of water is adding here and the hydrogen part is adding here according to Markovnikov's rule, right? So both these two compounds that as a product are forming according to the Markovnikov rule, and this reaction is known as hydration. Hydration is basically the addition of water to alkene. Okay, and how is the water molecule be added here? The water molecule is being added here by following the Markovnikov's addition rule, right? You can see the OH is the negative part of water, and it is attaching to this carbon atom, and because this carbon atom is actually containing less number of hydrogen atom. It contains one hydrogen, it contains two hydrogen, so obviously OH will be added here, na? And it is giving you this simple product. Now in case of second example also, out of these two carbon atoms, since this carbon atom does not contain any hydrogen atom, and this carbon atom contains two hydrogen atoms, so obviously OH group will be added in this carbon atom according to Markovnikov's rule, right? So this Markovnikov's rule is important. What is Markovnikov rule? What is the anti-Markovnikov rule? Explain this type of rules with example. So this type of questions you could expect in your exam, right? Now let's talk about the next reactions of alkene, where you can see the alkene that I have taken the most simplest alkene, that is called ethylene. CH2 double bond CH2, it is called ethylene. So whenever ethylene will react with BH3 or or boron trihydride, or you can say it as simple boron, then what will happen? This CH2 double bond CH2 will be turning into CH3 CH2 whole 3B. Okay, CH3 CH2 whole 3B. And in the next step, if you use the H2O2 in presence of OH minus, then CH3 CH2 part, only one part of this molecule, entire molecule will be connected with OH. So CH3 CH2OH will be your final product, right? CH3 CH2OH will be your final product, and this reaction is known as oxymercuration demercuration reaction. So what is oxymercuration demercuration reaction? When alkene reacts with BH3, it will give you trialkyl boron. Here the alkyl group is ethyl. This is ethyl, na? So triethyl boron. Okay, triethyl boron. When this trialkyl boron or triethyl boron will be reacted with H2O2 in presence of OH minus or in presence of NaOH, it will give you CH3CH2OH. Simply CH3CH2OH. Clear? Now the thing is that what is the role of this H2O2 acts as catalyst here, and what is your reagent? Reagent is BH3 and H2OH minus. What is your starting material? Starting material is alkene, CH2 double bond CH2. What is your product? Product is ethyl alcohol. Okay, so question could come, explain the hydrocorrosion oxidation reaction with example, right? So you can give this example as well. That's ethylene when reacts with BH3 gives CH3CH2 whole 3B, because three molecules of this fragment is actually reacting here. So this carbon will be CH2 will be CH3, and this CH2 will be, as it is CH2, and since three molecules are reacting here, so it will be CH3CH2 whole 3B. In the next step, CH3CH2 will be added with OH minus, since you are using H2O2 in presence of OH minus or in presence of NaOH. So CH3CH2 will get this OH minus to form this CH3CH2OH. Okay, and keep remembering in your mind that hydrocorrosion oxidation reactions always involve three molecules of ethylene. Okay, three molecules of ethylene. Hydrocorrosion oxidation always involves the three molecules of ethylene. That thing you must have to remember, right? Now next reaction is oxymercuration demercuration. So here you can see in the hydrocorrosion oxidation reaction, the alcohol that is being generated here actually Markovnikov's alcohol. Sorry, anti-Markovnikov's alcohol. Why it is called anti-Markovnikov alcohol? Out of these two product, since OH is adding here in this carbon atom, so it is anti-Markovnikov alcohol. That means you always find anti-Markovnikov product in case of hydrocorrosion oxidation method, right? Now in case of oxymercuration demercuration, another reaction is possible, that is called the reaction where the alkene part, that means ethylene, CH2 double bond CH2, will be reacted with HgOAc2, mercury diacetate, with HgOAc2 in presence of water molecule, and you will initially get this product, where this product will be reacted with sodium borohydride NaBH4 and OH minus to give you CH3CH2OH. Okay, so entire reaction, both the two reactions are called hydroboration oxidation and oxymercuration demercuration. So first part, actually these two reactions are actually single reaction. So first part of the reaction is called hydroboration oxidation, where ethylene is reacting with BH3 to form this compound initially, and it is finally reacting with OH minus to form ethyl alcohol. And second part of the reaction is you can think of as that ethylene is reacting with mercury diacetate and sodium borohydride to give you an alcohol. Okay, so hydroboration oxidation and oxymercuration demercuration, both these two reactions are very important here. Okay, now the second part of this reaction or another reaction that you can think of is that alkene. This alkene will be reacted with water molecule to give you simple dihydroxy compound. It is also very important reaction. So question could be given in this way, that alkene plus KMnO4 arrow A plus B. Okay, or simply A. So what is your A? A is your OH and OH. That in water part will contain OH, and that OH, 2 OH of water, since 2 molecules of water will be reacting here, so 2 OH group will be added in this carbon and in this carbon atom, forming this product. Clear? Now, in case of addition of alkaline KMnO4 with an alkene, now what is the product? If you use alkaline KMnO4, which is an oxidizing agent, good oxidizing agent, and then it will turn this hydrocarbon directly into the acid, and these two carbon atoms will form the acid. So the acid will be CH3COOH, and this carbon atom will be turned into this carbon dioxide. So who is the reagent? Alkaline KMnO4 in presence of acid. If you heat a reagent alkene with alkaline KMnO4 and an acid, we will get an acid. We will get this part as acid and this part as carbon dioxide. Okay, now next reaction is ozonolysis reaction. Here you can see in the ozonolysis reaction, this is an alkene and it is reacting with ozone. Since it is reacting with ozone, in the first step, O3 molecules, these O3 molecules will be connected with this compound CH3CH2 double bond CH3 in this way, where oxygen atom is attached with these two carbon atoms in this way and two oxygen atom here. Now if you make the bond cleavage or breaking of bond in this way, then you will get CH3CH2CHO, CH3CH2CHO, and aldehyde, and CH3COCH3, CH3C double bond O CH3, and a ketone. This compound is called aldehyde compound, and this is ketone compound. Okay, the name of this compound is propanaldehyde or propanal, and name of this compound is a ketone, that is called propanone. Okay, so this reaction is known as ozonolysis reaction. So what is ozonolysis reaction? When an alkene reacts with ozone, any alkene reacts with ozone, first intermediate is formed, that is called ozonide intermediate or mole ozonide intermediate, and if you make the bond breaking in this way, then this part will make an aldehyde and this part will make a ketone. Okay, since it is CH3CH2CH, so the compound will be CH3CH2CHO, and this part is CH3C double bond O CH3, CH3C double bond O CH3. It's up to you what reagent you are taking as an example. If you take CH here, not CH3, if it is H, then the second compound would be CH3 C double bond O H, that is CH3CHO. Okay, so both the two part will be an aldehyde and a ketone, either two aldehyde, either two ketone, or one aldehyde, one ketone. Okay, it's up to you what reagent you are taking as an example. Clear? This reaction is known as ozonolysis reaction, where ozone is reacting with this alkene compound, forming this ozonide, and in the next step it is reacting with zinc, and in presence of water it is reacting with zinc and water. Then ozonide is being broken here in this way to form aldehyde or ketonic compound. Okay, this reaction is known as ozonolysis reaction. So these are some of the most important topics of alkenes part. In the next class we will talk about alkyne part. Till then, thank you for listening.